corresponding to the 2s subshells. Okay. When L equal to 2, when L equal to 1, correspond to the 2p subshell. So there are 2 subshells in there. Now, in each subshell, the S subshell can only have 1 orbital. I'm talking about the ML value. Okay, and then the P subshell can have up to 3 orbitals in there. Px, Py, Pz. Now remember, we're talking about 3-dimensional space. Okay, so the dumbbell-shaped orbital can align with the x-axis, y-axis, and z-axis in the 3-dimensional space there. And then when you go to n equals to 3, we have 3s, 3p, and 3d. And for the 3d subshell, we have 5 possible orbitals in here. So as you can see, and this is more like an upside-down building. Pyramids is actually small on top and then large on the bottom there. And this is like an upside-down pyramid. So on the first floor, there's only 1 room in there. On the second floor, you have a total of 4 rooms, 1, 2, 3, and 4. And on the third floor, 5 plus 3 plus 1, total of 9 rooms there. So the higher you go in terms of n value, the more rooms you have, the more electrons you can accommodate. And this is how we distribute all of the electrons for all of the electrons in any of the atoms. So the third quantum number really is the orbital, the actual orbital where the electrons are. We call it magnetic quantum number, and it's the number of orbitals in the subshell. When L equal to 0, there is only 1 orbital. When L equal to 1, there are 3 orbitals. Now how do we represent those 3 orbitals? -1, 0, +1. So the numbers -1, +1, do not try to understand that number in the pure mathematical sense. It's like a room number. The first orbital, the first room, the room number is -1. Okay, so maybe in the basement, you can use a negative number to represent that. And 0 is another room number. +1 is another room number. Now, when you go up higher, when you go to the third level there are 5 orbitals there. So when you go to n equals to 3, then you would have a 3d orbital. Well, the ml values would be negative when you go to L equal to 2 actually, and there are 5 orbitals there. So -2, -1, 0, +1, +2, total of 5 orbitals there. Okay, so and it gives you the total number of orbitals in the subshell, and also determines the orientation, the spatial orientation of a particular orbital there. Remember, we're talking about the three-dimensional space there. So when you have a p orbital shaped like a dumbbell, they can align with the x-axis, y-axis, and the z-axis. And when you have a d orbital and shaped like 4 lobes clustered together, they can also take different orientations there. Okay, so and it gives you the orientation of an orbital there, and the value of the ml starts with -L, go all the way to +L, including 0. So in this case, the relationship between the ml and L is that ml, the number of ml, the number of values for ml equals to 2 times L plus 1. 2 times L plus 1, L, the value of L. If L equal to 0, 2 times 0 is 0, plus 1. So there is only 1 possible value for ml. It'll be 0. Okay. Now, if L equal to 1, 2 times 1 is 2. 2 plus 1 is 3. Total of 3 values. What are those 3 values? When L equal to 1, -1, +1, 0. Those are the 3 values. Okay, so this is how we assign a postal address to each particular electron. And remember, it is possible for 2 electrons to have the first 3 quantum numbers identical. How do we differentiate the 2 electrons with the 3 identical first quantum numbers? Well, MS, the electron spin quantum number. We'll talk about that in a little bit there. And the review of the relationship there. When n equals to 1, L can only have 1 value, 0. Okay. When n equals to 2, L could be 0, could be 1. When n equals to 3, L could be 0, 1, 2. And you probably notice the relationship. When n equals to 1, there is only 1 sublevel. When n equals to 2, there are 2 sublevels. When n equals to 3, there are 3 sublevels there. The number that we use to represent those sublevels is 0 when n equals 1, 0 and 1 when n equals to 2, 0, 1, and 2 when n equals to 3. And then, once we have the sublevels identified, when L equal to 0, the total number of orbitals that we can have in that sublevel is 0, because 2 times 0 is 0. There is only one value associated with L equal to 0. That value is 0. Okay, so this 1 here represents the number of possibilities, the number that we use to represent that value is 0. I know this may sound confusing there, but think of it as a room number in a hotel. Okay, and room number 256 doesn't really mean there are 256 rooms in this hotel. The first number 2 represent the floor, and then there may be 60 rooms on the second floor, and then, well, 256 is one of those rooms there. So that's one of the analogies that I can think of. And when you try to assign quantum numbers to electrons there, think of them as a room number in a hotel. Okay, so when L equal to 0, ML can only be 0. When L equal to 1, there are 3 possibilities and 3 possible numbers for ML. That's 0, positive 1, negative 1. When L equal to 2, 0, plus 1, minus 1, plus 2, minus 2, total of 5 possibilities. Okay, and then the quantum numbers and electron orbital there, again, this relationship, L equal to 0, that's the subshell, S subshell. L equal to 1, that's P. L equal to 2, that's D. L equal to 3, that's F. And then the number of orbitals that we can have in those subshells, 1, 3, 5, and 7, so on and so forth. And each subshell contains 2L plus 1, many number of orbitals. Meaning each level or each sublevel there, you can have that many rooms there. 2 times the number of sublevel plus 1. Now that plus 1 is because of 0 is always that possibility there. Now again, try not to understand all of these numbers in the pure mathematical sense. 0 means nothing. No, 0 is just a room number. We can have a room, we number it as 0. So go to room 0, doesn't mean the room does not exist. Well, there is a room there with a number of 0. And you find we're using that particular number to represent the room there. Okay, so the electron spin quantum number, there are only 2 possible values. Now that you understand the relationship among the first 3 quantum numbers there, and then if you can put 2 electrons in the same room, then there are 2 possibilities. Well, you have to be able to differentiate between those 2 electrons. So the MS, the electron spin quantum number, MS would be either positive 1 of 2 or negative 1 of 2. And by positive and negative, well, counterclockwise is defined as positive, clockwise is defined as negative. There's really nothing wrong if you say, well, I'm going to say this is positive and the other is negative. As long as you have one positive, the other negative, we're okay. But by convention, everybody who understands the basic chemistry there, well, we know counterclockwise and by convention is defined as positive. The other direction of spin will be negative. So that's something. Once you identify the first 3 quantum numbers, you pretty much narrowed in a particular room of a hotel. There are only 2 possibilities, there are only 2 people, and there can only be 2 people be assigned to that room there. Then one of them is going to be positive, one of